So we've done univariate statistics describing individual variables, which is very useful. But now we get to the crux of the matter. Bivariate statistics, in other words, the relationship between two variables, and testing hypotheses. In quantitative methods, we want to test hypotheses. We want to know whether there's a relationship between two variables, whether this is a causal relationship. For instance, warmer temperatures cause higher ice cream consumption, or simply correlational relationship. When ice cream consumption in New York goes up, so does the crime rate, but they don't cause each other. We also want to know the nature of this relationship. Is it a positive relationship? Is it a negative relationship? Or is it a typological relationship, particularly with categorical level variables? Now the tool that we're going to use to test the relationship between two variables is a contingency table, a cross tabulation. That's our building block number one. Now I know some of you start having a panic attack when you see numbers like this, but don't. Relax. Go through this presentation. So we construct this contingency table to test the relationship between two categorical variables, or two ordinal variables, or one categorical and one ordinal variable. And that's what we're going to do in this class. Now take this example. I constructed this table from the survey that you did online. There's a total of 25 respondents, and I asked students two questions. What is their preferred political party, and how satisfied are you with the current PTI government? 1 being the most satisfied and 5 being the least satisfied. Now the question here is, what's the relationship between these two variables? Now here it is clear that party ID is the independent variable, and satisfaction with the government is the dependent variable, or the outcome. We always put the dependent variable values in the rows. You can see them in the rows here. And we put the independent causal variable values in the columns, the party ID. So how do we put a contingency table together? And once we have it, how do we interpret the data? Well, to begin with, as mentioned before, the dependent variable always goes in the rows. Here it is level of satisfaction with the government. The independent variable, party ID, in this case, always goes in the columns. So then you write both the raw numbers and the percentages in each box. So how many Noon League voters were there that were very satisfied with the government? Somewhat satisfied, neither nor, somewhat dissatisfied, and strongly dissatisfied. And do that for each party. Then you calculate the percentages down. In order to do that, you should have the totals, a totals row at the very bottom, totaling the total of each value of the independent variable. So you calculate the percentage down. You always calculate it down. Once you've calculated the percentages, you look to see if there's any systematic difference in percentage across each value of the independent variable. So you calculate the percentage down and you compare it across. If there is no systematic difference in the distribution of percentages for each value of the independent variable, in this case for each value of party ID, then there is no relationship between the variables. But if there is a difference in how the percentages are distributed across each variable of the value of the independent variable, then there is a relationship. What does this mean concretely in this case? Well, here we can see that there clearly is a difference. Noon League voters, of them, or Noon League supporters, none of them are satisfied with the government, either very or somewhat satisfied, 0%. PTI voters are 83% of them are either very or somewhat satisfied with the government. People's Party supporters are 60% of them are satisfied with the government. So clearly, and then 0% of the Pakhtunkhwa Milli Awami Party voters. So very clearly, there is a difference across each value of the independent variable. So there seems to be a relationship between the two variables. All right, so you may ask yourself, how do I create a contingency table from data? Well, here we have a ready-made table of electoral results um, of the 2018 elections after some late by-elections in October. I don't know if it was the complete data or not. But we have two variables. You have party ID, which is in the rows, and you have legislatures, the National Assembly, the KPK Assembly, Punjab Assembly, Sindh Assembly, and Baluchistan Provincial Assembly. That is the other variable. And as we know, the independent variable goes in the columns, and thankfully enough, here the independent variable is in the columns, the location of the assembly, and the dependent variable is how many seats each party got in each assembly. Now, the one thing that is missing here is the percentages. There's just the raw data. The percentages is missing. Furthermore, we have to put the totals at the bottom of the table as well in order to create the percentages. So that's what we're going to do. All right, so what do we need to do first? We need to add up the totals down in the bottom column. Why? Because we need to calculate the percentage that each party gets in each assembly, in the National Assembly and then in the provincial legislatures. And as you can see, the National Assembly has 339 total seats, KPK has 114, Punjab 361, Sindh 164, and Baluchistan 47. Then we have to calculate the percentages. We calculate them down because we want to know how many seats, what percentage of seats in the National Assembly did the PTI get, or the Noon League. The key is not the absolute number of seats, but the percentage of seats, because some assemblies have more seats than others. So, what are the results? Well, to begin with, let's start with the PTI. We can see that the PTI got 40% of its seats in the National Assembly, 69% of its seats in KPK, 50% in Punjab, 18% in Sindh, and 15% in Baluchistan. So we can see that the location of the legislature does have an impact on the number of seats each party gets. There seems to be a correlation. Then, if we move to the Noon League, the difference is even bigger. It gets 25% of seats in the National Assembly, 47% in Punjab, only 6% in KPK, and just one in Baluchistan and none in Sindh. So there's an even bigger variation there as well. Clearly, where the provincial assembly is makes a huge difference as to how many seats each party gets. Let's move to the People's Party. The People's Party gets 60%, over half of the seats in the Sindh, but gets 0 in Baluchistan, and 16% in the National Assembly, 2% in the Punjab. Again, we can see that there is a clear variation. If there was no relationship between the variable of legislature and party, then the distribution would be the same for each party. Then the PTI should get about 46% of the seats in the National Assembly, in KPK, in Punjab, Sindh, and Baluchistan. It would be the same across each province. The location of the legislature would make no impact on the number of seats and the percentage of seats. But clearly it does. So there is a relationship between these two variables. Now, in the previous example, there already was a pre-existing table that just had to be tweaked a little bit to create a contingency table. But what if we only have raw data? Well, this is the case in this example. You see the raw data from an Excel sheet that was entered. Actually, this is from the online survey that you guys took. I tweaked it a little bit in order to make it a little bit more have a little bit less categories and make it a bit more simple. So now you have to enter this data into the table. First of all, you have to decide which one is the independent variable, which one is the dependent variable. Well, presumably gender is going to be the independent variable. It seems unlikely that political party ID will determine which gender you are. But gender might have an effect on which party you like. All right, so you know that independent variable has to go in the columns and the dependent variable has to go in the rows. So you create enough rows and columns for each value of the independent and dependent variables, and then you count. How many males were PTI voters, how many males were New League voters, how many males were People's Party voters, and so forth. And do the same thing for females. How many females were PTI voters, New League voters, and so forth. And then you put the total for males, 17 men, and 7 women. And then you calculate the percentages, because that's what you want to compare. It's all about the percentages. All right, now you've created the table, but how do we interpret the data? Well, in this class, you're going to be using what we call the eyeballing method, which is a little bit more than an educated guess based on what you see without doing any calculations. You compare the percentages across the columns. So let's have a look here. It seems like there is a similar percentage of male and female voters who like the PTI. 41% of males like the PTI, 43% of females like the PTI. Not much of a difference. Then we can look at those who voted for the Noon League. 18% of the men voted for the Noon League, 29% of women voted for a Noon League. So there seems to be a higher percentage of females. But remember, the overall number in the survey is quite low. So we don't know if it means very much. Then 11% of the People's Party, 11% of males voted for the People's Party, 0% of females voted for the People's Party, 18% of males preferred the Pashtun Nationalist Party, 0% of women, and then 11% of males had no party preference, and 29% of females had none. So it seems like there is a slight difference based on gender, but the sample size is so small, it could be due to random chance. Now, eyeballing will help you figure out whether there is a relationship between two variables. But of course, it is not statistical mathematical proof. For this, you'd have to do a statistical test. And so I advise caution for those of you who are intimidated by math. Now, I'm not going to ask you to know this, but I'm putting it here anyway so that you have it as a resource in case you want to dig into it more. Now, in order to test whether the relationship between two variables, and particularly two categorical variables, is statistically significant, we do what is called the chi-square test. Here you see the formula. Essentially what you're doing in a chi-square test is that you're comparing the expected distribution of values of variables if there were no relationship with the actual observed variation. If there is considerable difference between the expected distribution of values, if there was no relationship, and the observed actual variation, then probably there's a statistically significant relationship. But if there is no difference between expected and observed, then probably there is no relationship. Another concept that you should be familiar with if you're going to do this is the degrees of freedom concept, which essentially helps determine, once you have the chi-square value, helps you determine whether the relationship is significant or not. The degrees of freedom essentially depends on two things: how many cases you have, what is your sample size, and also how many values each variable has. So this is the chi-square test. Again, conceptually, just keep in mind this is testing the difference between the expected distribution of values if the null hypothesis were true, if there's no relationship between the two variables, and the actual observed variation. All right, so I've added the website there for you to figure out how to do the chi-square test in Microsoft Excel a data sheet. Now, some of you are familiar with SPSS. You can do it a lot quicker, but I'm just doing it with Excel because we're entering our data in an Excel file. So go to that website if you want to know more details about how to do it. But I calculated a chi-square value of 3.148, which was the outcome of that formula looking at the relationship between the expected value, distribution of values, if there was no relationship between the two variables, and the actual observed outcome. Now then, we have to also then look at the critical chi-square value that the chi-square test should have in order to be statistically significant. Now the degrees of freedom is 4, which essentially looks at the number of rows and columns that you have, and the sample size is 24, which is quite small. The critical chi-square value based on those that data is 9.49. At that point, we can reject the null hypothesis. Well, our chi-square value is 3.148, so it's lower than the critical square value, which means that the relationship is not statistically significant. One can also calculate the p-value of the chi-square, and this is 0.533. It ought to be 0.05. Again, you can look into it more in terms of what that means. All of that to say, the relationship is not statistically significant based on these two measures. What does this mean conceptually? Actually, well, it means, number one, that the sample size is too small. I actually did this operation by multiplying the data by 10, assuming that the sample size was 240 and that there was 170 males and 70 females and so forth. And if that were the case, actually the relationship would have been statistically significant. The chi-square value would have been higher. But the sample size was too small. The distribution of values could have been simply due to chance. And furthermore, the difference, there was not enough difference between party preferences of men and women. There's a little bit of difference, but based on the very small sample size, it's not enough to make it statistically significant. Now, if your head hasn't exploded already, we'll take a very quick look at how to read multivariate statistical analysis. In other words, how do you read statistical data where scholars have looked at the relationship of not just two variables, but a number of variables, hence multivariate statistical analysis. This is a regression analysis. The key thing, I'm not going to teach you how to do this, or not even the specifics of how they did it. I'm just telling you how to interpret the data. And there's really two things you have to keep in mind. Number one, look to the stars. And number two, look at the plus and minus signs. Those numbers that have stars, in that case, the statistical test showed that the relationship between those two variables is significant. Where there's no stars, there is no significant relationship, and it was probably the fact that it might have just been down to random chance cannot be discounted. Furthermore, you have to look at the plus and minus sign to see if there's a negative or a positive relationship. So let's look at three numbers here. We can see that percent of life spent in the U.S. Has a statistically significant, even though it's weak, but it's still statistically significant relationship with national identity. What that means is that essentially those people, the older you are, the more likely you're going to have a strong sense of national identity. That is a statistically significant relationship. Let's look at a second number. There's a correlation between being second generation and having uncritical patriotism. It's a negative relationship, which essentially means people who are second generation immigrants tend to have less uncritical patriotism compared to those who are not second generation immigrants, either first generation immigrants or not immigrants at all. So that is a statistically significant negative relationship. Second generation Americans tend to have less uncritical patriotism compared to others. Let's look at the third number. Black, African American, and national identity. there is a statistically significant relationship between being black and having national identity. In this case, it's negative, which means that African Americans, blacks, have a less national identification compared to other ethnic groups. That's what that means. So again, don't get intimidated when you get an article that does regression analysis or multivariate statistical analysis. Look to the stars and look at the plus and minus signs. All right, now it's your turn. We know that students don't learn unless they have to do it for themselves. As always, go to the discussion forum and start one discussion thread and respond at least to one other discussion thread that someone else started. Use that discussion forum to ask questions if something is not clear, or to help others answer their questions. Then there's the writing assignment as usual. This time you will have to create a contingency table from the data to the right. It's data from the online survey. There's two variables: party ID in the left column and province in the right column. Party ID is the dependent variable because it's unlikely that which party you prefer caused which province you are from. Rather, the province that you're from may or may not have an impact on which party you like. So this is how you should remember to put the dependent variable values in the rows and the independent variable values in the columns. Make sure to add the percentages by calculating them down. Then in 3 or 4 sentences, interpret the data from your contingency table using the eyeballing method. The eyeballing method, again, is to compare percentages across columns. Here's the test. Is there a systematic difference in party preference across different provinces? Do people from KPK or Balochistan favor parties to a different degree than people in Punjab or Gilgit-Baltistan? Don't copy and paste from your classmates, because you will have to do this on your own in your survey assignment, and your classmates won't be able to help you. So better to learn now how to do it. In fact, better to do mistakes but have made them yourself than to copy someone else's mistakes.